This is my gravity code. Here is an array that holds the key values, and it's the special key code values, so like up, down, and left, right. And here is a vector that just points downwards with a magnitude of 0.5. So that's the gravity. This is a bool that I use inside the character object. Here's the character object. Its position and velocity are both p-vectors. So I just start them out at 200, 200, and somewhere in the loop I call the update function, which causes him to fall. So the character's draw method is really simple. It just sets up a fill color and does an ellipse at the character's position.x and .y values. The update function, so in this program the ground is just a solid 300. If you had some kind of terrain data, you would need to get the y value of the terrain at that point and have that be dynamic instead of a solid 300. But if the y position goes below 300, then you stop its y velocity. You stop it from falling by setting this bool to false, and you might have the character be a little bit inside of the ground block because he was skipping frames as he fell, and it detects like right in here somewhere that he was falling. So you just reset the y position to the ground level. Next up, if not falling. So if the bool in falling is false. If it's not falling, then I'm going to detect whether they clicked the up key. If they did, I set the y velocity to -15. Well, as they're holding down the up key, this would subtract, but I immediately set falling to true, so I don't think that it will set the y velocity to anything. Like if I didn't have this, then I could hold down the up key and it would just accelerate faster and faster up. But since I have this line, this line only gets run once. So I set the y velocity equal to -15. If the left key or the right key is pushed, I'm updating the x position just linearly. And you can kind of tell by the motion that it's linear instead of like the up and down is like a nice parabolic trajectory, but the left and right is just as you're holding it down, you just modify it by 5 pixels flat. Here's where the velocity gets updated by the acceleration. I add acceleration to velocity, and acceleration was that gravity vector, which I just arbitrarily picked 0.5. There's no reason behind that other than it made the animation look good. And then after updating the velocity, I use the velocity to update the position. So using this p vector and the .add method, you get a nice parabolic trajectory. Oh, and here's my draw loop. That's the one last thing to look at. Background, draw the grass block, draw the character, update the character. I also have a spin-off I wanted to show you. So you can use the exact same code, modify it a little bit, and instead of having a character jump code, you use the same basic premise of adding p-vectors together, and you can create bullets, which I used for some of my tank games. So ACC is the gravity vector, but I have a bullets array and some other stuff. And wherever you click, it's going to spawn a new bullet as per the mouse clicked function. I pushed new bullet objects with the mouse X and Y coordinates and an angle and a multiplier. If you turn up the power, they will shoot off with a greater velocity because the power is multiplied by the trigonometric, like the velocity vector is the cosine and the sine of the input angle, and then the power scales those up. So in my tank code, like I put in the angle of the barrel into the bullet code and the power that the tank has achieved by picking up power packs. So that's that. I think I'll end the tutorial here.